Today we're going to be covering significant figures and how they relate into measurement. Now I want you to think back to the measurement lab we had already done. We're going to think about what we did and how we can improve it going forward. A key component of all measurements involve accuracy and precision. Accuracy is how close we are to the quote correct number. Precision is how repeatable our values are. Anytime we're taking measurements, we have to use significant figures to determine what place to report our values to. The definition of significant figures is very useful. The definition itself can actually describe to us how to use any measurement device we could want. The definition of significant figures is all digits that we know for certain, or known with certainty, plus one uncertain or estimated digit. In order to use that definition, we read all of the digits that we know, or the device tells us for certain, so all of the digits that it has passed, and finally we estimate for a final digit. So each measurement must include an estimate. Different devices have different positions for their estimates. For example, balances could estimate to the 100th of a gram, to the 10th of a gram, and in some cases to the 1000th of a gram. So we have to be able to identify by looking at our device exactly where we need to report our measurements to. A key component of this is knowing if a digit is certain or not. A digit can only be certain if all 10 graduations or marks are indicated on the device. For example, for the ones placed to be known for certain, all digits from 1 through 9 have to be marked in between the tens place. Let's go to the lab and see what this looks like with different devices. Now that we've talked about what significant figures are, let's see how it can relate into measurements as well as precision and accuracy. We're going to use the definition of significant figures to be able to learn how to read each different device that we might be using in a lab, or any device we might be using to take a measurement in general. The first device we're going to look at is a triple beam balance. First thing you need to do anytime you're using a triple beam balance is make sure all of the riders are set to 0 at the far left. After you've made sure the riders are set to 0, you need to look at the far right where your balance is set and make sure that those lines line up. In this case they don't, which means the balance still needs to be calibrated. In order to calibrate it, you need to look at the left under the pan. The calibration knob for the triple beam balance is underneath the pan. You need to adjust it until the balance lines up. In this case, the balance is higher than 0, so I need to move the mass inward. So I'm going to turn the knob so that the mass goes inward. As I get close, I'll make finer adjustments. I'm going to start by making a large adjustment until I see that it's very close. And then once I get close, I'll start making finer adjustments. In this case, I've overshot it a little bit, so I need to bring it back out. I'm going to make a fine adjustment, let the balance steady, and see where level is. When you're checking to see if the balance is calibrated, you want to get down to eye level to make sure you're looking at the proper level as you go. Now we're ready to measure the mass of our object. The object I've chosen for this one is a roll of tape. You put the object in the center of the tray and always start with the 100 gram rider. In this case, I move it up to 100. That's too much mass. I then move to the 10 gram rider, making sure to find the notches each time. After it drops by, I know I've gone too far, so it's not quite 60, but it's more than 50. Finally, I use the 1 gram rider, and I recommend using a pen or a pencil to help this move, because it does stick to your fingers, and at this point it rides freely, so we need to make sure that as we're adjusting it, we are making fine movements. At this point, I'm going to continue moving it until the lines on the right line up. Now that I can see the lines have lined up perfectly, I know that this is balanced out, and I can record the mass. Using the definition of significant figures, I can measure the mass now. I use all of the digits I know for certain, or I know for certain that it is more than. In this case, using the tens rider, it is more than 50. Using the ones rider, it is more than 6. So I know the mass is 56, and I can zoom in on the ones rider to be more precise with my measurement. After I zoom in on the ones rider, I notice that each mark between the 6 and the 7 is 1/10 of a gram. Because each 1/10 of a gram is marked, I know that digit for certain. In this case, I know it's 56.6 because the rider is pointing just to the right of 0.6 grams. Now, I use the last part of the definition to make an estimate. In this case, the mass of the roll of tape is 56.62 grams. I'll give some leeway as you're making measurements because the last digit is an estimate. You get a little bit of leeway. I would accept anything from 0.61 to about 0.63 or 0.64. Another type of balance you might see, and we will periodically use this year, is either called a centigram balance or hanging pan balance. It increases the precision of your mass measurements because it introduces another rider at the 1/10 of a gram position. As you can see after I've zoomed in, it's marked for every 1/10 of a gram, and in between every 1/10 of a gram we see 10 marks. So this one is precise to the thousandths place because every 100th is marked. For this type of balance, the calibration knob is up here on top. That is how you calibrate and make sure that your balance is accurate. After I have my balance calibrated, I put the object that I'm interested in measuring the mass in the pan, and I follow the same procedures. I start with the 100 gram rider, the 10 gram, the 1 gram, and then I move to the 1/10 of a gram rider. As you can see, this balance is a little more difficult to use. It takes a little more care because of the added precision. Now that it's balanced out, let's take a look at the reading. To read this, we read all the digits known with certainty, so everything that we know for certain that it has passed. We know that it didn't pass 100, so our first digit is the 5 in the tens place for 50. Our ones measurement is 6, so we know it's 56. We then move to the 1/10 of a gram. We can see that it's very clearly past 0.7, so it's 56.7 something. I'm going to zoom in on that section and take a closer look. After I've zoomed in into this section, I see that the arrow is pointing just to the left of a mark. The last mark that it has passed is 0.77. So at this point I know it's 56.77, and I have to make my estimate. Because the arrow is much closer to the mark on the right, a good estimate for the thousandths place in this case would be 9. So the mass for this object is 56.779 grams. Something to consider when you're measuring the mass of something that can't be directly set on the weighing pan is to use another container to measure it. For example, if I had a sample of water in a graduated cylinder that I wanted to know the mass of, I would then need to find the mass of the container that I'm going to put it in first. So I determine the mass using the riders. I would then pour the sample into my container. I would then measure the mass of the container and the sample and subtract out the mass of the container to measure the mass of the water. So anytime we need a sample that cannot be directly put on, such as a powder or a liquid, you'll have to use a container such as a beaker or weighing boat, and you'll have to subtract out the value of that beaker or weighing boat. The next set of tools we're going to look at are tools that measure volume. We're going to start with the beaker. Looking at the beaker, the first thing we should notice is that it is only marked for every 100 milliliters, which tells us the only digit we know for certain is the hundreds place. So our estimate will be to the 10 milliliters in this beaker. So generally we don't want to use a beaker to measure volume. We can use it if all we have to do is estimate, but a beaker would not be the best way to measure volume. Next up we have an Erlenmeyer flask. We can see that it's only measured every 50 milliliters, so it too is only precise to the 10 milliliter mark. Erlenmeyer flasks typically aren't used to measure volume for that reason as well. Next up we have a graduated cylinder. Graduated cylinders can vary in how they're marked. I'm going to zoom in on the marks and we're going to figure out what place that the graduated cylinder is precise to. When I zoom in, you can see that there are 10 marks between 60 and 70 milliliters. That means every 1 milliliter is marked on the graduated cylinder. Using our definition of significant figures, we know for certain every 1 milliliter, so our estimate in this case will be to the tenths place. So let's take a look at how to read a graduated cylinder. When I'm using a graduated cylinder, I want to make sure that the plastic collar is near the top. It's an extra layer of protection to help prevent breaking. This isn't used to measure, it's just to help prevent breaking if it were to get knocked over. When I'm ready to start measuring with a graduated cylinder, I can pour either from a beaker, a flask. I want to pour from some device into the graduated cylinder, and I want to get close to the value that I want to measure. In this example, I want to measure 50 milliliters, so I'm going to fill the graduated cylinder up until it gets close to 50 milliliters. And remember, when you're pouring, you want to commit at the beginning and the end to prevent spilling. I need to get air bubbles out. I can gently tap it on the table or gently tap the graduated cylinder to get the air bubbles out, because they will affect my reading as well. When I read it, there's a couple different options. I can either lean into it to read, or I can lift the graduated cylinder to read it. You want to pick one of the two. You do not want to squat down. If you squat down, you expose yourself to getting spills on your body. So you can either lean into it, or you can carefully lift the graduated cylinder. If you hold it near the top, you can make sure that it stays level and vertical that way. Once you've gotten to eye level with your graduated cylinder, you want to make sure that you're reading the bottom of the meniscus. The meniscus is the curved surface of the liquid that we are measuring. In water's case, the meniscus curves down, so you'll see two distinct layers where the water is at. We want to make sure we are always reading the bottom one. And remember, this graduated cylinder is marked for every milliliter, so our estimate comes in the tenths place. In this case, I can see that the water is past 52 milliliters, but the bottom of the meniscus has not quite made it to 53 milliliters yet. So I would call this one 52.8 or 52.9 milliliters. In this graduated cylinder, the meniscus is much easier to see because it's a narrower graduated cylinder. Again, we read all the digits we know for certain. We know that it is past 8 milliliters. And I notice that each tenth of a milliliter is marked on this graduated cylinder. So I know that position for certain as well. I can see that it is past the third mark, so it's at least 8.3. Again, reading the bottom of the meniscus, it's not quite to 8.4 yet, so I would read this as 8.38 or 8.37 milliliters. The last device we're going to look at in this video is a meter stick or a ruler. For a meter stick or a ruler, it measures typically in centimeters. So each mark is a centimeter. When you zoom in, you will see millimeter marks, or tenth of a centimeter. Let's take a look and measure the length of an index card. I make sure to line up the end of the meter stick with the index card, because in this case 0 is right at the end. Some rulers 0 is offset, so you'll have to be careful on how you line that up. You can see that every tenth of a centimeter is marked, so we know that digit for certain. Our estimate comes in the hundredth of a centimeter. I'm going to zoom a little further in so we can see a little more clearly. We know that it is at least 12 centimeters. In this case, I can count that it is past 12.6 centimeters, very close to 12.7. So the length of this index card is about 12.68 centimeters.